Recording. Last time we met, we talked about routing protocols. What's the difference between dynamic and static routing? Taylor Early? Dynamic versus static routing.
Dynamic is implemented, basically configuring the routing tables.
Forget all that stuff. In your words, your understanding of dynamic versus static.
Static is manual, dynamic is automatic.
How does it do it dynamically? Static is manual. You type it in either through a user interface, graphical user interface, GUI, or through a command line. And dynamic is done through automatically, but how?
The routing information protocol.
That's one of the protocols. There are multiple protocols. That's the point.
I got
Well,
another one.
Go ahead. No, yes, Sean, or Austin.
DHCP.
No, routing tables are not built through DHCP.
No, what is it? That's automatically signs. I'm thinking about
DHCP will tell you what router to use. Absolutely, you can assign a gateway using, or other routers using DHCP. But the way it finds its paths to the other routers that are out on the network, a router can do that dynamically through what? RIP is one example. RIP2 is another example. What are those things called? What are those programs called? Austin Howell?
Distance vector routing.
I can't hear.
Distance vector routing.
Okay, so that's how it does it, but what is the category of software that we're talking about that RIP is an example, RIP version 2 is an example? What are those called? Quinn? Routing protocols. It's that simple. It's that simple. Routing protocols. Okay? And that's how you set up dynamic routing. Now, if you're doing routing with anything other than a small local area network connected to another small local area network, which makes it a wide area network, if you're doing anything other than that, chances are you're going to use a router that uses dynamic routing protocols to identify what's on either end and beyond either end. Okay, so we're not actually going to configure dynamic routing protocols because the ones that they have you do RIP, we don't use anymore. RIP2, we do use. OSPF is another one, Open Shortest Path First. Now, based upon that name, Open Shortest Path First, what we talked about last time we were together, what do you think is, how does that protocol work? Yes, Jason?
It uses the metric system, and it will go to what's the fastest route.
It could be either the fastest route or the shortest route. So in other words, the fewest number of hops. Yes, Jessica? Is what? Does, okay, so the question Jessica asked was, does OSPF take into consideration security when it determines the best path? If the requirements are there for secure connections, like a VPN, it absolutely will. Okay, it's a very flexible kind of protocol. And so depending on the requirements of that route, it will only allow you the secure connection, even though it may be 5 hops versus 1 hop, or 2 hops, whatever. Does it always use the most secure? No. No. As the slide here says, Monitored network routers had a change in their link state, meaning that they were turned off, turned on, or restarted. Now, why is it monitoring? What is that first bullet talking about? What does that mean? Anyone know? Why are they putting that up there? Why is that first? Why does a router that's using OSPF monitor the network for other routers that are just booting up or being rebooted or whatever? Don't hurt yourself there, Austin. Go ahead.
I mean, which one is the fastest, best, option that you use? Or something?
Well, eventually, yes. Awesome.
Well, if a router is just starting up or booting or something, they're pretty much unusable for a certain amount of time, so it would be a terrible idea to send it to a just booting router.
Not really. Good guess. Yes.
So we can choose a different path to send the packets?
Okay, if it's shutting down, it could choose another path. What else?
If theirs was turning on, there might be a lot of other traffic if they turn it off, so it can go somewhere where it's not too clogged up.
Yes, all of those things it absolutely will take into consideration. But here's the other thing. Yes, Mike?
If I was just turning on, it might, that path without router creates might be faster than others.
Exactly. It's querying those new routers that are just turning on or just rebooting to see if it's got some other paths that it needs to know about. So it's going out and saying, hey, you just came on board, what do you got to offer me? And then it's measuring those metrics, and then it's identifying what is available, what networks are on the other side of that router, and what's in its routing table. What does it have access to? So that's the benefit in that first bullet. That's the real benefit of OSPF in that it dynamically and automatically goes out, and if a router reboots, then it says, okay, I knew what you were doing before, now tell me what you've got available now. Or if a new one comes on board, broadcasts out and says, hey, I'm here, then it will go out and say, okay, what do you got? What kind of routing do you have available on your particular router? Probably the most commonly used interior gateway protocol. What's interior gateway protocol? And don't just read the last bullet up here. What are we talking about? Give me a scenario where OSPF makes sense. Yes, Austin.
So, interior gateway protocol, isn't that for like firewalls?
Actually, it's probably not for firewalls. Probably not for firewalls. Yes.
Overcomes like the limitations of
It definitely does that. But when we're talking about interior gateway protocols between and connections between autonomous systems, what are we referring? This is opposed to what? Yes.
Exchanging information between routers.
OSPF is the most common used in an interior gateway protocol for exchanging information. Yes, all of this is true. Yep.
like servers.
Let me just, as opposed to out on the internet. Okay, OSPF is the most commonly used routing protocol, dynamic routing protocol in networks that have multiple routers, but not necessarily the most common on the internet. And that's why firewalls isn't necessarily the answer. Is OSPF used out on the internet? Absolutely. But in a corporate network or in a school network, as an example, where you have 10 different buildings, 10 different routers, 5 different routers, whatever, OSPF is most likely the most commonly used, even today. Okay? Now, well, let's go with the slides.
Mr. Freeze,
Yes?
if it's so common and so good for these networks, why doesn't it be,
Can anyone say why it's not necessarily the most common for the internet? Yes?
I would think that because there's such a massive amount of routers turning on, turning off, restarting, that it would jam up everything.
It's chatty. Yes. Kind of like broadcasts. It's not going to be the fastest for that kind of environment. Okay. IGRP, different than interior gateway protocol by itself. Okay. Proprietary protocol used in large networks to overcome the limitations of RIP. Maybe that's what you were saying earlier. IGRP is used regularly. BGP, here's one that is definitely being used today, and here's how this would be used. Picture this scenario. I'm a company that has what we call a customer-facing website. What do you think I mean by that? Customer-facing website, Larry?
I'm not sure.
Yes.
Easy to use website for customers.
Not necessarily easy to use. It could be a difficult website to use, but a customer-facing. Yes.
What they see when they log into the website.
It's what they see. Okay, so in other words, Mossberg has customer-facing websites and it has internal websites. Customer-facing websites, anybody in the world would access it. Okay, or like an intranet site for just employees for getting employee information. It's still a website, but it's only for internal use. Customer-facing website means that it's on the internet, it's available to anybody in the public. Chances are, if you've got a customer-facing website, it's critical that that website is up and running. Now, my website, in fact, Hoosier IT Service doesn't even have a website anymore. I don't even bother with it because all my business is done through referrals. Hoosier Driving Academy, the other company, absolutely, it's critical that it's always up, right? So I've got monitoring stuff on it and everything else. But in a company like Mossberg, several $1 million a year company, that's their lifeblood. That website has to be up and running. And so there are certain things that could make that, what are certain things that would make a website go down? Unable to access. Jason?
Virus attack.
A virus attack on the website, on the server itself,
Extreme amounts of traffic.
like a denial of service attack or just a huge amount of traffic. You've got a new product that everybody loves, they see it on Shark Tank, and at 9:10 p.m., 3 jillion people go to that website to buy this new product. What else? Maybe the domain is expired. I had that happen. Didn't pay much attention, and the domain expired and is no longer accessible. There were no more DNS rules. What else? Another reason why you can't get to a website. This is the one that I'm really interested in. Not necessarily an attack on the server, not necessarily loss of DNS data, but what? What's another one? How do people get to a website, a public website? Austin? That's the protocol. That's the protocol on the server. How do they get to it? Through the internet, through an ISP. So if I have a customer-facing website, I obviously have to connect with an ISP, an internet service provider. I have to have a pipe coming in so people can see my website. Well, what happens when that pipe goes down? That's when we use BGP. If I have Comcast as my main connection to my web... All right, we'll come back. Turn that off, please.